transformation to functions. Remember we said if you put a negative out in front, that flips it upside down, right? If you put a number out in front, like 2 or 7, that makes it stretch, right? Because it's a big number. But if you have a small number, like a decimal or a fraction, put your phone up, please. Put your phone up, please. If you have a small number like a decimal or a fraction, it does what we call compress, right? It makes it wider, pushes it down. And then we said if you have something inside the parentheses with x, that moves these left and right, opposite of where we would think. And then a number here on the end moves things up and down, however much it says, right? Okay. Oh, I accidentally gave you the wrong paper, didn't I? Okay. I don't have coffee papers there. And we'll go with the flow, and then I'll go get you one credit right after we finish. Sorry about that. You probably weren't complaining. You were just going to keep quiet. And so you got the paper, right? Okay. So it says on here, if f of x equals x squared, write the equation of the new function g of x under the following transformations. All right, so the first thing that we're going to do is just write the equation like what we've been practicing doing. Okay, so we know that anytime we have a function, it looks like this equation up here, right? Okay, and we're going to write down whatever changes they say are happening. So here it says that we are going to shift right 4 units. Okay, so left and right shift. Where does that go in the equation? So we put it in front with the A, in the parenthesis for C, or at the end for D. In the parenthesis, right. And remember, we always do opposite of what it says. So they did not say any stretch or shrink, so I don't need anything in front. I'm going to go ahead and make my parenthesis. If it says right 4, and it's opposite of what we think, should it be x plus 4 or x minus 4? Minus 4, good. Okay. All right. And then it says shift the vertex f of x to the point 5, negative 3. Okay, so remember in a coordinate point, the first number is x or y? X. This is representing a change in x, while the negative 3 is representing a change in y. Okay, so x's go left and right. So they're saying instead of being at 0, 0, like normal, I'm now over here at 5, negative 3. So it did look like this. Now it's the same u, but it's been moved over here. All right, did they say anything about a stretch or compression? No, so I don't need anything in front, but we can tell we definitely moved left or right some. So I'm going to need some parentheses for my x. Did it move to the left or to the right? To the right, so we put minus. Very good. Squared. And did it move up or did it move down? Down. How many? 3. Okay. So we've written both of these equations, but if you look at the second half of the question, it asks which one of these equations down here is equivalent to what we just wrote. So it wants us to simplify the equation we came up with. So if you notice, it says we're going to square this entire parenthesis here. What does it mean to square something? Multiply it times itself. So x minus 4 squared really means x minus 4 times x minus 4. And we actually practiced doing this just a couple units ago. Remember, you multiply everything in your first parenthesis by everything in the second parenthesis. So first I would multiply x times x. What's that? X. What is it? X squared. Very good. But I also am going to have to multiply that x times that negative 4. What is x times negative 4? Negative 4x. Very good. And now we have to do the negative 4. So what is negative 4 times x? You just skipped one spot. It's okay. What's negative 4 times x? Negative 4x again. And then negative 4 times negative 4, which is positive 16. Okay. So we've done all the multiplication. Remember, the next thing we check for is to see are there any like terms that we could combine. So you guys see anything we could put together? The negative 4x's. Good. What is negative 4x minus 4x?
8.
Negative 8. Good. So really I have x squared minus 8x plus 16. So which one matches that? 8. Yeah. Okay. All right. Same thing here. They said we need to square this, right? So this is going to mean this is what we have written, but they really want us to do x minus 5 times x minus 5, but don't forget we do have this minus 3 out here on the end, right? Okay, so we're going to go ahead and multiply exactly like we did over here. So I've got x times x, which is good. And x times negative 5, which is very good, negative 5x. And then I have this negative 5 times x, which again is going to be negative 5x. And then we've got negative 5 times negative 5, positive 25. So we're done multiplying, but what else do I need to tag on the end? The minus 3. Okay. Then we look for any like terms we can combine. Is there anything that is the same that we can go ahead and put together?
5 and 5.
The 5 and 5, good. Okay, so no x squared, that one stays the same. What is negative 5 minus 5? Negative 10. So I got negative 10x. Any other like terms?
25 and 3.
25 and negative 3. What is 25 minus 3?
22.
Perfect. All right, so which answer choice would that be? Good. Okay. I see. All right, this one says the equation is going to reflect across the x-axis. Reflect, what does that mean we have to have at the beginning of our equation? A negative. Nice. So I've got a negative. Then it says it's going to shift up and left. Did it say anything about a stretch or compression? Okay, all right, so we don't need a number in front. Did it say we shifted left or right any? So I'm going to need a parenthesis, right? Which way did it say it went? Left. So I'm going to put x plus or minus? Plus. Plus 6, right? Then we put our square out there. And did it say it went up or down any? Up 2, so what am I going to put? Plus 2, very good. Okay, and then again, it wants to know which one of these it's equivalent to, right? So you could do exactly what we just did on those first 2. You could FOIL it out, right? Or I'm also going to show you how you could do that in your calculator. So in order to do it in your calculator, you're going to type this in Y1, exactly as it's written. So in my Y1, I'm going to have negative parenthesis x plus 6 squared. No, what was it? Plus 3? Plus 2. Okay. And then in Y2, you pick any of those equations from the answer choices, and you're going to put it in Y2. So which one do you guys want to start with? A? Type in A first. Okay, well then we'll put in negative x squared minus 34 in Y2. So negative x squared minus 34. All right, and then we're going to hit graph, and if they're the same equation, then they land right on top of each other. If they're not the same equation, we're not going to see the same picture 2 times, right? So, does it look like they're the exact same picture?
Yeah.
Yeah. So those are going to be equivalent. So I know that A is going to be my answer choice. Let me pick one of the other ones just to show you how you would know that it's not. So let's say I put in b. So for b, I'd have negative x squared, and then what is it? Minus 12x, and then minus 34. And then I hit graph. There's the first one. Uh-oh, it's not fitting on the screen. That could be our problem too.
Oh no, it's like first it was just the blue line, and then the red line went right over it.
Okay. All right, then we did something wrong on the first one. Maybe I misentered. Did I put the?
No, I think you did.
Okay. Okay. All right. All right. So you can check it by seeing if they overlay. If they don't overlay, obviously it's not the same equation. Okay. All right. So on number 4, it says that it's going to translate the axis of symmetry. So remember, axis of symmetry is that x equals a number or y equals a number? X. Very good. So axis of symmetry normally is at x equals 0 because it's normally got a vertex at 0, 0, right? But it says it's going to move it 7 places to the right. So now it's going to be over here at positive 7. So instead of my U-shape being here, now my U-shape is here at 7. And it stretches by a factor of 2. Okay, so I'm going to put my stretching compression where in the equation? Where does that part go? At the end, in the middle, at the front? Front, yes, good. So it says it stretches by 2. Did this thing move left or right any? Yeah, so that part goes in parentheses. Is it going to be plus 7 or minus 7? Minus, right? Because it's always opposite of what we think. Does it say it went up or down any? No. Okay. So again, I can either type it in my calculator, putting this in y1 and checking it against these, or you can FOIL it out like we did up at the top. Just remember, whenever you're FOILing here, if that's what you choose to do, you're going to end up having to multiply all 3 pieces together, right? Okay, so you could go ahead and distribute this 2 into that parentheses if you'd like. You'd have 2x minus 14, okay, times your x minus 7, which that's fine if we do that. We'd have 2x times x, which would be 2x what? What's x times x? X squared, good. And then we'd have 2x times negative 7, which is negative 14, right? And then I have negative 14 times x, which is also negative 14x. And then I have negative 14 times negative 7. What's negative 14 times negative 7? Positive 98. Good. Just kind of ran out of room there, didn't I? 14x plus 98. All right, and then those 2 are like terms, right? So I would have 2x squared minus, what's negative 14 minus 14? Very good. And then we still have our plus 98. So that would match A, right? Okay. All right, flip it over onto the back. And it says, for each of the following, we're going to find the vertex, the axis of symmetry, the maximum or minimum, and the domain and range. So if it's written like this, with the parentheses, we don't have to type it in our calculator and make the calculator find it. We should know, okay? So remember, normally, it starts at 0, 0, right? In the parentheses, it says minus 5. Does that mean it moved to the left or to the right? To the right. So when I move to the right, I get a positive number, right? So it's now at 5. And then does it say it moved up or down? Down 1. So now my U would be over here. So that's my vertex. Okay. Okay, so remember the way we determine if it opens up like these U's or if it is flipped upside down is if it has a negative in front, right? Is our number in front positive or negative?
Positive.
Positive. So it looks like this, right? So is my vertex a maximum or a minimum when it looks like this? A minimum. Very good. So this one is a minimum. And then it asks for the axis of symmetry. Well, just like Josh said earlier, axis of symmetry is always x equals a number, right? What was our x? Good. Okay. And we also know that in a parabola that the domain is always what? Our real numbers. Good. And then the range talks about if it goes up or down. Well, if mine looks like this, it's going up, right? What's the lowest we said that it ended up going to? -1. So from -1 and up, or y is greater than or equal to -1, right? Okay. Over here, remember these numbers are what tell me where my vertex is. So -1, does that mean I went left or right? Right 1 spot. And +4, does that mean I went up or down 4? Up 4. Okay. And then remember, I look out in front to see if this thing has been flipped upside down or if it's right side up. Is ours upside down or right side up? Upside down. So it looks like this. So is it a maximum or a minimum vertex? Maximum. All right, and like you guys said, domain is always what? Very good. Okay, and then my range. This time it's up here and going down. What's the highest it went? 4. And then from there it goes down or gets smaller. So y is less than or equal to 4. Good. All right. Next one. Vertex. So remember, that's the numbers in here and out here that tell us how it moved. So in here, did it go left or did it go right? Left. So that means it's now a -4, right? Did it go up or down any? So where is it still at? Good. Okay, I look out in front. Is mine upside down or right side up? Up. So is that a maximum or a minimum? Minimum. Okay, and where's my axis of symmetry? Nice. All right, and then last one in this section says, where is the vertex? So again, remember that's in the parenthesis or out here on the end. Did it say it moved at all? So where is it still at? 0. All right. So that means it's the normal U-shaped parabola. Is that a maximum or a minimum? What's my domain? Good. And my range? Yes. So y is going to be getting bigger, right? So greater than or equal to 0. Nice. All right. Okay, number 9. First, they ask where the vertex is. So remember, that's this coordinate point right here. So where is that point at? -3 for the x value, and where for the y value? -1. Nice. Okay, so now we're going to put it into an equation. So first of all, it's upside down, right? So I know it needs a negative. Okay, and it definitely has been stretched some because it's kind of skinny. But we can probably help narrow that down once we figure out something for in the parentheses. So there is going to be a number there. We're not completely sure which one just yet. Did it move left or right any? Left. Okay. So left means I put x plus or x minus? Plus. The 3, right? And then did it move up or did it move down? Down. All right. So, if you want to know if it was a stretch or a shrink, we can always go through here and we check, 1 to 1, and obviously it's skinnier, right? Okay. If it was doubled, if you guys remember, if it was by 2, then I'm multiplying all of my x's by 2 to give me the new y. So if I multiplied 1 by 2, I would get 2, right? If I multiply 1 by 3, I'm going to get 3. So if I check for all my points, like if I went down 2 over 4 would have been what it originally was. I'm checking from here to here, so it's a little bit skinnier here, a lot skinnier here, right? It went to 2 instead of 4. Well, what do you do to turn 2 into 4? What do you multiply by? Times 2. So that lets us know it's going to be the one with the 2 in front. So what's my answer choice going to be? All right, and then last one says, which of the following graphs has a parabola with a vertex at -10, 0 and goes through this coordinate point? Okay, so you have options on how you could find it. You could solve it by hand, or you can always type your equations into the calculator and pull up your table and see what meets that criteria. So let's say we're checking out answer choice A. So I would type in answer choice A, which is 2 parentheses x plus 10 close parenthesis squared. Okay. Now I'm just going to pull up the table. So I pressed second graph, and we said that it needs to have the coordinate point -10, 0. So I'm going to go check at -10. Okay, so it does have -10, 0, and it also said it has the point 1, 60.5, right? Does this one have 160.5? Okay, so I know it's not that one. I can try the next one. So the next one says 1/2 x plus 10 squared. So now I'm going to switch out that 2 for a 1/2 and check the table. All right, so first I check my -10. It does have -10, 0. Does it have the point that we want at 1? It says 121 divided by 2. What is 121 divided by 2? So it does have it, right? So that's going to be our answer choice. So you can always just type it into your calculator and check the table if they give you multiple points to check. All right?